에너지 경제TV에서 녹화 중계한다는 점 안내 말씀드립니다. 두 번째 트랙의 마지막 주제는 스마트미터링, 저렴한 예산으로 소비자들의 행동을 이끌어내는 법인데요. 이 주제는 스위스 취리히연방공과대학교 에너지연구소 베레나 티펜백 연구부장님이 발표를 해주시겠습니다.
Thank you very much for having me here. I'm very pleased to be here. The title of my talk is Smart Metering, How to Effectively and in particular cost-effectively influence consumer behavior using behavior-specific feedback. So I'm going to talk about a different kind of smart metering than normally is referred to as smart metering. Let me briefly give you a short overview on the group that I'm working with. I'm actually a member of the Bits to Energy Lab, which is a research collaboration mainly of ETH Zurich, but also of two other chairs. And what is a bit special about our group and the research that we do is that our team is very interdisciplinary in the sense that most of us have a technical background, so we have a lot of computer scientists or electrical engineers, or in my case it's mechanical engineering, but we also have psychologists and people with a background in economics or management. And you might ask, well, why this kind of diversity? And the reason is, the mission of our lab is actually to bring technology, and in particular information technology, together with insights from social sciences, so behavior-focused insights. That sounds a bit weird at the beginning, but I'll tell you now why we actually combine these two worlds that are sometimes quite far apart. So technology on the one side, with a focus on information and communication technology, ICT, and behavior. So one other important aspect about the research of my group is we try not to do just academic research, but it's important for us that the research that we do also has a practical impact, so a really big impact on the real world and on households and energy consumption in the real world, and not just some academic papers coming out of it. So this is the reason why we work with a lot of partners from industry, with startup companies as well, and also with public authorities. So most of our projects currently are in Switzerland and in Europe, but increasingly we are also doing projects overseas. We did a project in the United States. We're starting a project now in Singapore, 2 projects actually, and we also hope to do a project here in South Korea soon. So, well, South Korea and many other countries in the world have put forward very ambitious energy efficiency goals. So in the European Union, for instance, the goals are called the 20-20-20 targets. So the name has a lot of 20s in it, and it's actually goals that are targeted for the year 2020. And there's 3 main goals, and the first one is increasing energy efficiency by 2020 by 20% compared to the baseline year 1990. The second goal is to, have a 20% share of renewable energies in the energy consumption. And I would like to emphasize that it's energy and not just electricity here. And the third part is reducing carbon emissions by 20%, also compared to the 1919 year baseline. So again, all these goals do not only focus on electricity, but overall energy consumption. And this is important because when we talk about smart metering, most smart metering projects, they only focus on electricity consumption, which is of course a key area in this, but it's not the only one. Another important aspect, I think, is a lot of the projects and efforts in smart metering, they go into technology, which is important, of course. There are major challenges to the implementation of smart metering. For instance, dealing with privacy issues, data security. But even as an engineer and as somebody who works at a university that is very technology and hard science oriented, we've come to the conclusion that the technology side is probably the simpler side. It's only one side of the coin. I mean, yes, it's challenging, but it's probably feasible. The side that is much more complicated is probably the behavioral side, because when you face it, technology is kind of predictable in most cases. It's sort of reliable, not always, but most of the time. Whereas human behavior, I mean, it's just messy. And at the same time, behavior is one of the areas where probably there's also a huge benefit for energy reduction and for conservation potential. Let me just give you two brief examples. For instance, car manufacturers. They put billions of dollars into improving the efficiency of engines by 1%, maybe 2%, and it really takes a very long time to do this. At the same time, when you look at drivers, so people driving the very same car with using the same technology, the fuel efficiency varies by a factor of 2. So, as an engineer, it can be frustrating. You put all these efforts to improve it by 1 or 2%, and then the end users increases the consumption by a factor of 2. It's even more extreme in other domains of behavior, like showering, for instance. We did a study in Switzerland that showed that the spread between the 10% of the least efficient shower users, they use 8 times as much energy and water as the most efficient users. And this is true for so many behavioral domains. When you think of modes of transport, purchase decisions, lighting, and so on. So behavior is really a big deal, I think. And this is also one of the reasons why, one of the key benefits of smart metering is actually geared on behavior. So for consumers, there are, of course, a lot of other benefits, and for utility companies in particular. So smart metering has benefits, obviously like load shifting or like reducing the cost of meter readout. But at the same time, one of the reasons why many regulators, so market regulators or government put it in place is the hope that it would also empower consumers, because right now we're in a situation where most consumers, they have no clue what uses how much electricity or energy in their homes. They just get a bill every month or every year, and at the end of the day, they have no clue how they could actually cut their consumption. And so many governments and regulators hope that smart metering could also address this by making consumption more transparent. Well, the problem is it's not working as well as people had hoped. So there were some initial studies that were really very promising that indicated that smart metering projects would yield energy reduction, conservation impact of between 5 and 15%, so really a lot. And the idea was that the information that is collected by smart meters is not only being sent to the utility company, but that it would also be sent to a small in-home display, so people could see in their household, oh yes, I'm using that much electricity or energy right now. And just seeing this, receiving this kind of feedback would actually make people more aware of their consumption, and that way they would reduce their consumption. Actually, the European Union has put forward a directive in the year 2009 that said that by the year 2020, again, 80% of the households should have a smart meter installed, in the hope that people would then be in control of their electricity consumption and energy consumption and cut it down. Well, the thing is, those smart meters or the in-home displays that are connected to them, they typically only show aggregated data on household electricity consumption. And most people actually don't know what to do with that. So it turns out that actually bigger programs now of smart metering pilots, they show that the typical reduction is only between 1 and 5%. So really disappointing compared to the initial hopes why many programs had been put in place. I still believe that smart metering is really promising, and we should really put a lot of efforts into it, but probably we have to rethink a bit this behavioral side of it. This is, for instance, an Australian study, and you can see that they show that it was issued last year. It's a meta study on many smart metering pilots that had been put in place. And this study shows that the early pilots, they had very high potential, so they projected these 15% savings. But over time, now that those programs have become bigger and bigger, it shows that, yeah, typical value is rather in the order of 3%. And this study also concluded that with this low level of reduction in households, those smart metering projects are not cost effective anymore. And so they actually disadvised against it. And also many projects in Switzerland and in the United States, they have come to on hold, or at least put on hold for a while before this issue is addressed. So even if you don't care about behavior, it might endanger smart metering projects that also have other benefits. Actually, when you face it, it's not too surprising that the impact of such programs isn't bigger. This is a typical image of the kind of in-home display that is provided in the United States or in Europe at this moment. I mean, it does not look too exciting, to be honest. And what you can see as a consumer is that currently you're spending 15 cents, US cents per hour. Well, most people think, well, 15 cents, I can afford it, I don't care. Well, you could show this information in a bit smarter way, in the sense that if you use electricity at this rate, you actually spend $1,300 per year. And that's information that people will probably care more about. So you can see that a lot is about the way you present information. The other thing is it displays things like 590 watts and a certain amount of, well, kilowatt hours that's being used. The problem is that a lot of people, they cannot relate to these figures. They don't know the difference between watts and kilowatt hours, so for them it's just meaningless. And even those people who know about those, well, measures, what does it tell them what they should change in the home? I mean, what does it tell them if they don't have, does it tell them if they don't have efficient appliances, or how could they actually change their consumption? How could they actually reduce it effectively? So we should really not expect that people will start investigating like detectives and start chasing down the last kilowatt hour. I think we need to provide better information. And that's one of the things that we're trying to focus on in my lab, so really bringing together technology and behavioral insights. And one of the key lessons that we learned is that it's really important to provide information to people that is clear and that is precise. So really focus on a specific behavior and also provide the information in real time and not only 2 hours later when it's too late, basically. So one of the most promising projects that we've done so far is a project on water heating. And I'm going to talk about this now because this project actually yields a reduction in energy and in water consumption of 23%. And we do this through real-time feedback on a specific behavior, which is showering. So shower behavior, that sounds a bit weird at first. Well, but when you look at the numbers, it's not that weird anymore, actually. So I also brought 2 of those devices with me, which I'm happy to pass around. I would just be happy if I could collect them at the end of the session. Could maybe somebody just pick them up and pass them around? Thank you. Okay, thank you. So these little devices, which you can have a look at now, well, they actually show people how much energy and how much water they're using in the shower, right when they're actually taking the shower. So why do we do this? Well, first of all, water heating is the second largest energy end use in European households, in US households, and as I learned, apparently also in South Korean households. So it's weird because most people who think of energy conservation, they only think of lights, switching off lights. Yeah? But it's actually much less effective than thinking about your hot water consumption. And this is a huge missed opportunity because actually for smart metering, hot water consumption is a perfect, well, ground to start in the sense that users have very high control of their usage. Water is very visible, so it's not as abstract as electricity consumption, but you can feel water, you can touch it, you can see it, so it's much easier to understand for users. So that's a good starting point for feedback. And also in a shower, you have less distractions. You don't have your cell phone in your shower, so you, as an information provider, you actually get a chance that people will look at the feedback that you're providing. So it's actually a perfect candidate for smart metering, and that's why we focus as a first project on this water consumption side. So the little devices that are circulating around now, they are actually installed between the shower hose and a shower head in handheld showers. And if it's anywhere in the world, nearly everyone who has a handheld shower should be able to install it. And you don't need any tools to install it. It's really very simple and straightforward. So the users we had, nobody reported a problem with installation. So what does the device do? Well, it displays the amount of water and the amount of energy you've been using since the beginning of your shower. So you really see in real time how much water you're currently using and how much energy. It also displays the water temperature and a small energy efficiency class that is also illustrated by a small polar bear animation. So the longer you shower and the more energy you use, the uncomfortable this environment gets for the polar bear. So the device is really just displaying information, but only by doing that, it has a big impact. And a nice feature is also that the device does not have a battery. It's actually harvesting the energy for its consumption from the water flow. So what does it do? What impact does it have? Well, we wanted to figure that out in a study, and that was the study that I was conducting with several colleagues. We actually implemented this device in 700 households in Switzerland who used it for 2 months at first only. And we collected data from nearly 47,000 showers. So our goal was to find out, does this thing have an impact and how big is it? And on a second level then, why do people actually respond to this kind of information? And are there specific user groups where it has a particular big impact, or is it just working on everybody? So these were questions we were investigating. The research was carried out by ETH Zurich and also by the University of Lausanne, another Swiss university. The project was funded by the Swiss Federal Office of Energy and also by the utility company in Zurich, EWZ. And we worked closely with a startup company, Amphiro, which is a spin-off company of ETH Zurich. So what we did in this experiment was we had those 700 households, and 1/3 of them received a device which was, the device only displayed temperature, so it only showed water temperature throughout the entire time. We had chosen those households randomly to make sure that was our control group. So basically, if you see a change in consumption otherwise, it could also be seasonal factors, but by having this random control group, that's the baseline that we're measuring against. And then also we had 2/3 of the households who received real-time feedback on water and energy consumption. And what happened there was the first 10 showers, they also only received information on the water temperature to collect data before they get feedback. And after the 10th shower, they received real-time feedback. And now what happened with that? Well, what you can see is here on the left, the baseline period. So you can see that during the first 10 showers, they behaved just like the control group. So there was no statistical difference between those groups. But then as soon as the feedback kicked in here in the 11th shower, actually here, where the line is, you can see that they dramatically reduced the consumption on average by 23%. And those savings were sustained over the entire period of the study, over the 2 months. And 23% savings, that's huge, at least from a relative perspective. But you could still say that, 23%, that's nice, but it's only shower. So is that really that big? Well, the thing is, the same households who had participated in our study, they had also participated in an electricity smart metering study before. And in that study, they had only reduced the consumption by 3%, 3.2 to be precise. So when you look at the absolute figures now, in the electricity smart metering study, the yearly savings were 86 kilowatt hours of electricity. In our study, it was 443 kilowatt hours projected to 1 year for one household, so factor 5. Now, energy doesn't equal electricity, but actually from a carbon perspective, the savings of our studies are even bigger when you look at the carbon output, because in Switzerland, water heating is more carbon intense than electricity. It's because the Swiss electricity is mainly powered by nuclear and hydro, and water heating is mainly with oil and gas and electricity. As a result, the impact of our study was 8 times as big in terms of carbon reduction as the electricity smart metering in the same households. Plus, you have benefits of 8,500 liters of water per year per household, and the money, the cost savings for households are also much bigger. I should say that the cost savings, it really depends on the country, on the cost of water and of energy. But in Switzerland and in Europe, it's definitely cost effective to conduct these projects. So what are we gonna do now? Well, we're actually gonna carry out additional studies because the first study has already answered a lot of questions and shown that it's really very promising to give this kind of behavior-specific real-time feedback. But we want to find out a bit more still. So about the behavioral mechanisms. Why do people respond to it? Because we want to make sure that it's not some peer pressure or negative feelings, and apparently it's not the case from what we've seen so far. But we want to take this to the next level. We also want to make sure that the impact gets even bigger by adding things like goal setting or things like social norms, which are a very established concept in social sciences. And by adding these components, we think that the impact of these devices can be even bigger. On the technical side, so of course the findings that we generate, it's not only relevant for showering or hot water consumption, I think it's also very relevant for electricity smart metering and other behaviors like driving or like purchasing behavior. On a technical side, we also want to take it a bit further. We are currently working on a Bluetooth version of the device so that we also are able to have a two-way communication with the users and to adapt the feedback that he receives to his behavior and to really the specifics of his situation. And we think that then the savings will be even bigger. So there's still a lot of work to do, but so far the results are very encouraging. And with that, I would like to to conclude and to thank you for your attention. Thank you very much.